Okay, so we'll be discussing the PAVE question paper. So in question number 1, the statement is on TV, the reflection of walls are also visible when the TV is off, whereas when it's on, the reflection don't appear that strong. So here they are talking about the intensity of the light. So when multiple sources are giving light, like light from multiple sources are reaching your eyes, then we will be able to see only that which has the largest intensity. So initially what is happening is light coming from the outside source, it's the TV and it's reaching your eyes or reaching the camera here. So because of that, since that is the only source which is emitting light, like, or basically this TV is reflected that particular light and reaching your eyes, you can say that you are able to see those reflections. Whereas now when the TV is switched on, then light is coming directly from the TV and also light from outside is reflected here, and again that is also coming. Since this intensity is greater, if simultaneously some 90 I naught intensity is reaching your eyes and also 5 I naught intensity is reaching your eyes, then that 5 naught I naught will automatically become dim. Same way, if this 90 I naught becomes 200 I naught, then relatively that 5 I naught will become even more dimmer, so it's difficult to see that. That's the basic principle in this particular case. So here we have the options are when TV is on, light from the light TV's LED reflect the incoming light and neutralize them. So there is no concept of light is neutralizing another thing. So this does not happen, thereby reducing the amount of reflected rays. Amount of reflected rays will not be reduced. Same amount of light will be reflected now also, but compared to that, something extra is coming from the TV. So even the same amount of reflected rays coming to our eyes, light from the TV's LED will dominate. So that is the correct statement. And if the light outside is switched off, then the reflections will appear less prominent. Then in that case, yes, the light number of rays which are reaching will be less. So this will be less prominent. So these are correct statements, correct statement B and C. And if you increase the brightness of the TV, then reflection will appear less prominent. Again, what I talked about. So all three are correct statements. So the incorrect option is A. So answer for this question is option A. Then in the second question is regarding mirage formation. So in case of mirage formation, where it appears like there is some water on the road, whereas if you, that will happen only when you look at far distance. Whereas if you see very close, you will not be able to see that phenomenon. This again because of, in this concept of mirage, the air which is closer to the ground, that will be hotter and it will also be less refractive index. So as light so whatever light rays are coming, by the time before they hit the ground, so whatever incident ray is starting from the top, if just like the ground, so before it reaches the ground, it should attain some, it's always continuously going from denser medium to rarer medium. So it will keep on bending away from the normal. The air which is coming from top to bottom, hot air which is in contact with the ground, it will exchange heat energy with the ground. So the air remains in the ground, which is in contact with the ground, will be slightly hotter. That will also have less refractive index, whereas the air above will have more refractive index. So here it will keep on bending away from the normal, away from the normal. At one point, if the angle of incidence is greater than the critical angle, then total internal reflection will happen. So when you look straight down, what will happen is the angle may not be crossing the critical angle. But if you're already looking at little bit far away, then in that case, again for the same set of rays, it will bend away from the normal. At one point, it will become greater than the critical angle. Then it will immediately reverse. So to an observer who is standing here, it will look like this light ray is actually coming from the ground. So if an object is kept over here, some large tree, the rays which are already starting at some large angles, they'll ensure that the incident angle will become greater than the critical angle. So this will undergo total internal reflection, which is why this observer will think like this tree is getting reflected, light coming from the tree is getting reflected from here. This gives an appearance that there is a water actually here or some reflecting surface here. We have this principle of reversibility of light, right? Where if an observer is also standing here, then if you look straight down, then probably that will be only due to rays which are traveling like this. Whereas if you look far ahead, then that will be due to ray which has undergone TAR and eventually reaching you. So looking straight down, you will see the ground, but looking far ahead is when this appearance of mirage will come, which is why the option for this rays coming from closer object are not able to reflect from the ground and come to our eyes because they make small angle with the vertical, whereas critical angle is very low. So this is the angle with the vertical. If the angle with the vertical is very less, it is not yet crossed critical angle. So these days don't suffer TAR, whereas the rays which are going at some large angle, they'll be suffering TAR, and to this observer it looks like it is getting reflected. That's why if you see the camera captured from here, looking nearby, you are seeing the ground, but far away it starts acting like reflecting surface, which gives the appearance of water. So option A is the correct statement for this. Again, mirage becomes stronger when sun gets covered up by clouds is not correct because this mirage effect is more when it is hotter. So only in hot places you can see this effect even more pronounced, like in deserts. And this statement, air near the road is denser, is factually incorrect because the air near the road will be less refractive index, optically rarer. And question number 3. Here is regarding current through the 20 ohm resistor. So first we can combine all this resistance to find what is R equivalent. So the R equivalent for this entire branch is going to be 1 by 30 plus 1 by 15 plus 1 by 20 plus 1 by 12 plus 1 by 10. So this will be 2 by 30 plus 1 by 30, 3 by 30, which becomes 1 by 10 plus 1 by 20 plus 1 by 12. Again combining or taking directly now LCM 60. So 6 by 60 plus 3 by 60 plus 5 by 60 plus 6 by 60. This is 1 by 3. So the equivalent resistance of the entire right hand term is 3 ohms. Now total current passing through the circuit will be equal to, since this entire thing is together 3 ohms, so the equivalent resistance will become 5 ohms. So all these are in parallel combination. So together the total resistance across all the devices put together is 3 ohms. Now we have 2 ohms and 3 ohms are in series because the equivalent circuit will be 2 ohms and 3 ohms connected in series to 100-volt battery. So the total current coming from the battery will be equal to 100-volt by 2 and 3 in series. So we get 5 ohms, which is 20 ampere. So if the total current coming from the battery is 20 ampere, then we can say immediately potential drop across this 2 ohms will be equal to the total current I into R. This will be 40 volts. And potential drop across 3 ohms will be equal to same I into R. But now R is 3 ohms, 60 volts. So 20 ampere is passing through this 2 ohms. It will drop potential of 20 into 2, 40 volts. Same 20 ampere passing through this, it will drop a potential of 60 volts. So here 40 volt is dropped, here 60 volt is dropped. 60 plus 40, the total potential drop 100 volt with the battery supplied. Now once you get that, the potential drop across the 3 ohms is 60 volt. 3 ohms is actually connected between point X. 3 ohm is the equivalent resistance between point X and point Y. So if we say potential drop across this equivalent 3 ohm is 60 volt means it is potential difference between the point X and Y. Since these are all connected in parallel, potential drop across each of this resistor will be 60 volt. Now if you want current through the 20 ohm resistor, that will be equal to potential drop across 20 ohm resistor V equal to I into R. The 20 ohm resistor is connected between point X and point Y. So potential drop across this is equal to 60 volt divided by 20 ohm. So 3 ampere will be the current in this. So similarly, if you want potential drop across 10 ohm resistor, potential drop across 10 ohm resistor is also 60 volt. 60 volt potential drop divided by resistance will give you current through this. This will be 60 volt by 10 ohm, which is 6 ampere and so on. So in this question, this is what is asked. Current through the 20 ohms will be 3 ampere. Then in question number 4, for the LED to glow. Now if LED has to glow, then current should flow through the LED. So this is the path in which current should flow. Now if this switch is kept in on position, then it will be like a short circuit. Then current will start from the battery and flow through this path. So if switch 2 is kept on and switch 1 is also on, then current will flow through this. It will act like a short circuit. So no current will pass through the LED. So because of this, the only way in which LED is glow is if current is coming from the battery. For that, this should be in on and this should be off. So there is no other path for the current but to go through the LED and come back. The answer for this will be 1 should be on and 2 should be in off position. Then question number 5. So we have a plane mirror and also a concave mirror. So where should the object be placed so that images formed by the plane mirror and the concave mirror will coincide? Now if an object is placed at a distance x from the plane mirror, then for plane mirror the image will also be formed at a distance x. Now this should also act like the image of the concave mirror also should coincide in the same place. Which means even for this concave mirror, this will be your image when this is the object. Which means the object distance will be equal to incident rays in this direction from object to the mirror. From the pole, you measure the object distance. So object distance from the pole, you have to go in opposite to the direction of incident ray. So this is the direction of incident rays. So U will be equal to minus of this particular distance, which is 50 minus x. V is equal to 50 plus x, but again from pole we are going opposite to the direction of incident ray. And focal length is given as 16 centimeters. 1 by V applying mirror formula. 1 by V plus 1 by U is 1 by F. 1 by minus of 50 plus x plus 1 by minus of 50 minus x. Focal length for a concave mirror is negative because radius of curvature is again opposite to the direction of incident ray. Focal length is also same direction as radius of curvature, so that is also opposite to incident ray. So F is minus 16 centimeters. From this we can get the value of x. So cancelling the negative sign and all the three things. And then taking LCM, 50 plus x plus 50 minus x, 100 divided by a plus b into a minus b. So a square minus b square. So 1600 is equal to x square equal to 0. X square is 900. So the value of x is 30 centimeters plus or minus, but x is a distance, has to be positive. So fifth one, C will be the correct answer. And question number 6. Here, to demonstrate law of reflection, we are using laser light and the mirror is surrounded with smoke. So the smoke particle is mainly for scattering the light in all directions so that the visibility becomes better. And this is explained by Tyndall effect. So this presence of smoke is mainly for scattering the light in all particular direction. This is a theory question and this will be the correct answer for this. Question number 7. Birds sitting on high current wire don't get shock. So this is mainly because the resistance of the birds is very high. Because of it, the entire current will pass through the wire itself. So one important thing is these transmission cables are not coated with insulating. This option D. Transmission cables are not coated with any insulating layer, which is why they are dangerous and you are not supposed to. You have to be careful with that. The reason they don't have insulating layer is that will increase the weight too much, thereby for a long distance it becomes mechanically impossible to do that. The resistance of the bird is significantly low, so that high potential difference is not created across them. So in this case, if the resistance will become low, then whatever potential difference is there between these 2 points, because of that, high current will pass through them and that will be damaging. This basically is wrong and this what is correct. If the resistance is very high, then you can say that no amount of entire current is passing through the wire itself. Question number 8. So purpose of fuse wire in an electrical circuit. So fuse wire is made thin so that it can offer high resistance and limit the current during normal operation. This is not correct. During normal operation, we don't want the fuse wire to, limit the current. It just has to allow the current to flow through. The purpose of fuse wire is if suddenly large current comes, it has to somehow break the circuit to prevent any damage. Statement B, it is made very thin so that its mass is very less and it can get heated quickly with a small amount, thus melting quickly. This is what happened. Whenever current crosses beyond a particular point, it should get heated immediate and melt immediately, thus breaking the circuit. That is the role of heat wire. Copper is used in, again, copper is for normal connecting wires that cannot be used for your making the fuse wire. Fuse wire should be protected by the appliance. Again, appliance has to be protected by the fuse wire. So out of all this, B will be the correct answer for them. Question number 9. They are showing the formation of image on a screen. For this, they are using convex lens only. This because concave lens won't be able to form the image of the object on the screen. This is correct because concave lens will never form real image. If the object is kept in front of the concave mirror, it will always form a virtual image. This is the correct statement. If the white screen is removed, then also image will be formed. Only then is, and you can definitely capture it with the camera. If you cover top half of the screen with black paper, then also complete image will be formed. So for option C and D, so when you have a lens, the important property of this lens is if you have a point object or even a some size object, extended object, all the rays starting from this point will meet at the same place. So whether you take it starting from down or you take it starting from here. So the rays starting from a single point, all of them will converge at the same place. So because of which, if you cover this part with the black light, then the number of rays will get reduced. These rays will no longer be able to reach here, but still these rays will meet here. If you cover the bottom part with the black light, black color cloth, then this lens, this part will be opaque. Light cannot pass through this part, but still they can go here and meet here. Still that image will be formed. So the complete image will be formed. The only thing is intensity is less. So in both the cases, what will happen is if you cover one half with black paper, intensity of the image is less. But the complete image is formed even if you cover it. And it will be formed at the same location. Question number 10. So if the light bulbs in the room is switched on, image of the candle will become brighter. Again, no. It will appear darker because some other light will also get reflected from the screen and it will reach your eyes. So this will appear dim compared to that. Same as what we saw in the very first question of this paper in the TV, which is reflecting light. We are able to see the inverted image of the flame because of specular reflection. Now, specular reflection is regular reflection like a plane mirror. Because of specular reflection, then you can see the image only from one small location. On a wide screen, whatever image is formed, from wherever you stand, you can see the image, means it is getting reflected in all particular direction, irrespective of the incident rays. This will be diffuse reflection. This statement, it's not because of specular, it is because of diffuse reflection or irregular reflection. So this is also not the correct statement. If instead of widescreen we place mirror at a particular at the location, we can see image also only from specific location. Yes, that is correct. So if a plane mirror is kept over here, then that plane mirror might have some field of view. This light ray will hit here. This light ray will hit here. So maybe it will have that field of view where only from this range you can see. If an observer is standing here, he might not be able to see the image because no ray will reach his eyes. So that is the correct statement here, option C. The image will be visible, but only from certain locations. In question number 11 and 12, so here they're asking ray diagram is given, an angle theta you have to find. So since first this angle is given as normal, I think it is. So since this angle is given as 90 degrees, the dotted line is actually your normal to the glass slab. So because of which this angle will be 90 degrees. Since the total angle is 90 degrees, top half is 60 degrees. So the remaining will be 90 minus 60, 30 degrees. Now again, since this is also normal 90 degrees, so this angle is also 90 degrees. So now we have your quadrilateral. Sum of all four angles 360 degrees. So this angle is 120, this angle is 120, this angle is 90. So this angle is some alpha. And 120 plus 120 plus 90 plus alpha are the four angles of this quadrilateral. Sum of the four angles should be 360 degrees. So we get the value of alpha as 30 degrees. Now it is given that the final ray is parallel to the base of the prism. So if the ray is parallel to the base of the prism, which means this line and this line are parallel, then automatically these two becomes alternate angles. So this angle also will be equal to alpha. And since we got the value of alpha as 30 degrees, this angle will be, because this is the surface, this is the normal. If this is alpha, total angle is 90 degrees. So the remaining angle will be 90 minus alpha. Now applying Snell's law here, when it goes from glass to air, so at point 2, it is going from glass to air. So refractive index glass into sine of angle of incidence is equal to refractive index of air into sine of angle of refraction. Angle of incidence is angle between the incident ray and the normal, which is basically making 30 degrees. And the refracted ray is making 90 minus alpha. 90 minus alpha is 60 degrees. So root 3 by 2. The refractive index of glass, we get this as root 3. Which is what is the next question about. So for 12th one, the answer will be root 3. And for 11th one, they're asking for angle theta, for which we have to apply Snell's law at this point. This is for a 2, we are applying Snell's law. Similarly, at 1, if we apply Snell's law, refractive index of air into sine of angle of theta incidence will be equal to refractive index of glass into sine of angle of refraction. So 1 into sine theta is equal to root 3 into sine of angle of refraction is angle between refracted ray and normal, which is 30 degrees. So theta is equal to 60 degrees. So for 11th and 12th, the answer is C. And then question number 13. When only the first lens is used, image is formed at A. And we're asking for what is the initial distance of the object from the lens. So let the distance be equal to some x. Now in initial and let this distance also be equal to some y. So when only f1 is used, u equal to minus x, object distance b equal to plus y, and the focal length will be equal to plus 60 centimeters. So 1 by v minus 1 by u is equal to 1 by x f. So 1 by y plus 1 by x is equal to 1 by 60. Now when both f1 and f2 are used, object has to be shifted by 125 centimeters. But which side you have to shift it, that is not given in the question. So the main thing is you have to find how to shift the object. So in which direction should the object be shifted? Now if both the lenses are used, then definitely the power of the lens is greater. Because convex lens is converging lens. This is also positive power, this is also positive power. So if both the lenses used, power of the system will increase. So power is a measure of degree of convergence of divergence. Here, since it is convex mirror, it will converge more. So if initially the rays are going through this and converging here, after passing through two lenses, so if after passing through the first lens, it's converging at one point, maybe I can just draw it with some different colors. So if only first color is there, first lens is there, if the rays are converging like this, now if you put both the lens, this will be the same, this will be the same. Now definitely it will converge one more time after passing through the second convex lens. So the image will form more closer. So we know as you move the object towards the lens, the image will also go farther. Basically, if you want the image distance as fixed, then it would have converged once, it would have converged again. So object will get converging, like the light rays will get converging will get converged 2 times after passing through first lens also, after passing through second lens also. So from this you can easily identify that because of two lenses, if you fix the object, image will come closer. If you fix the image, object should come closer. So the ray diagram will be like something like, so the first lens will bend it little bit, and then second lens will also bend. So it means for same image distance, object should come closer. So if object is coming closer, then we know that object has to be shifted 125 centimeters. So we know the new location is going to be like, so object is now present at a distance of x minus 125. An image is formed at a distance of y. Now applying lens formula, u will be equal to minus of x minus 125. V will be equal to plus y. And focal length is 1 by focal f equivalent is 1 by f1 plus 1 by f2. Now applying lens formula, 1 by v minus 1 by u is equal to 1 by equivalent focal length. Equivalent focal length is 1 by f1 plus 1 by f2. Now we can replace 1 by y because x is what is asked. They're asking you for the initial object distance. So 1 by y we can substitute from equation 1. 1 by 60 minus 1 by x. So from equation 1, 1 by 60 minus 1 by x plus 1 by x minus 125. Solving this equation, you will get the value of x. This will be 125 into 30 is equal to x square minus 125x. So this will be x minus 150 into x plus 25. The value of x will be positive. We consider only the positive value of x. The initial distance is 150 centimeters. The next 14th question. The magnification obtained for position of the object shown is 1 by 4. So this is a convex mirror. This will form a virtual image which is erect, and 1 by 4 is the size. So let the initial object distance be x, and the image distance will be equal to y. And in fact, focal length is given directly. So we can use the formula for magnification as f by f minus u. That is equal to height of image by height of object. Since it is erect image, height of image is also positive. Height of object is also positive. So the magnification is positive because it's an erect image here. Focal length is also positive for convex mirror because incident ray and from pole to focus both are in same direction. So focal length is plus 80 divided by 80 minus u is equal to 1 by 4. Or we get 320 is equal to 80 minus u. So we get the value of u as minus 240 centimeters. So the initial object distance is minus 240 centimeter. And the same way, if the size of image is 2 by 5, Then same formula. This is M1 and U1. M2 will be equal to again F by F minus U2. For some other object distance, same mirror produces magnification of 2 by 5. So 80 by 80 minus U2 is equal to 2 by 5. So 400 is equal to 160 minus 2 U2. So 2 into U2 is minus 240, or U2 is minus 120 centimeters. Now using this part, since object distance is 240 centimeters, now they're asking for a distance between old image and new image. Which means initially if this was the object distance, then the image distance will be y1. So magnification is minus v by u minus y, v is plus y and u is minus x1. So y1 by x1 is equal to 1 by 4. So y1 will be equal to x1 by 4. Initial object distance is 240 centimeters. So y1 will be equal to 240 by 4, 60 centimeters. So initially this distance is 60 centimeters and this distance is 240 centimeters. Mirror is moved in such a way that new object distance is 120 centimeters. So if the mirror itself is moved till the time object distance becomes 120, which means mirror is moved till exactly halfway. This is the new location of the mirror. Now the new object distance is 120 centimeters. Now the new image location will be equal to, again magnification is y2 by x2 is equal to 2 by 5. Y2 is equal to 2 by 5 times new object distance is 120 centimeters, because whatever is magnification, that is image distance by object distance, similar to what you got for first case. So y2 will be 48 centimeters, where this will be your x2, and whatever is your new image location, that will be your y2. So y2 came out to be 48 centimeters. In fact, y2 comes out much closer than. So distance between the two images is asked. So y2 value is 48 centimeters. So if this length is 48, out of 240, this is 120. So remaining length is 120. So in this diagram, 240 minus 120. So the remaining distance will be 120. (120 minus 48). So the remaining distance will be 120 minus 48, which is 72. And 72 plus 60. So the distance between I1 and I2 will be 72 plus 60, which is 132 centimeters. So the D will be the correct answer for this. And question number 15. We are saying this is a spherical mirror and they're asking for which of the following is incorrect. So the pole is between A and B such that A to pole by B to pole is equal to O to A by I to B. So here, first of all, if you need this is your object and this is your image, the image that we are getting here is virtual and sorry, the image that we are getting here is erect image. Since it's an erect image and also magnified, because you can clearly see that from the principal axis, this is your object height and this is your image height. So it's an erect and magnified image. This is possible only by concave mirror, and that also when object is between focus and pole. So which means immediately we can end up putting that the concave mirror is actually in between. So now you can take this ray and this will be your pole. So we have two triangles where this is the angle of incidence, then this will be your angle of reflection. Both are equal. These two are vertically opposite angles. So these two angles are also equal. So when you take this triangle and this triangle, so incident ray hitting the pole, same angle it will come down. Angle of incidence equal to angle of reflection. And this angle and this angle are vertically opposite angles. So we get this two are same angles, 90 degree, 90 degree. So third angle is also same. So these two are similar triangles. So triangle OAP similar to triangle IBP. Then OA by IB will be equal to AP by BP. That is correct. Then the second statement is center of curvature is to the left of AB such that now center of curvature, what is the speciality? If the ray appears to come from center of curvature, then it will go back undeviated. So again CA by CB, CA by CB, which means again we are getting one set of triangle, similar triangles. Triangle CAO is similar to triangle CBI, because for both this triangle and the bigger triangle, angle C is common, 90 degree, 90 degree. So third angle is also common. Again, we have similar triangles. So CA by CB will be equal to OA by IB. So again, this statement is also correct. The focal length of mirror is the left of point A such that FA by focal length is OA by OB. Focal length is definitely to the left of point A. FA by focal length is equal to OA by, but OB is given here in denominator instead of IB or something. So this is not going to be a correct statement. So this will be the incorrect option. So C will be the incorrect option. So this is basically drawing ray diagram and similarity of triangles. Question number 16. If this is, they're asking what is angle theta. So if this is incident ray and this is reflected ray, angle of incidence will be equal to angle of reflection, which means whatever angle incident ray makes with the mirror, same angle reflected ray also should make with the mirror, which means this angle and this angle also should be equal. So if that is 120 degrees, this is also 20 degrees. Now they are saying this is horizontal, this is also horizontal. Which means these two are alternate angles, 20 degrees. Now this is a triangle 120, 20. So the third angle will be, sum of these two is 140. So 180 minus 140. 40 degree is the third angle of the triangle. Now again, whatever is the incident angle and makes with the mirror, same angle reflected light also will make with the mirror. So if this side is 40, other side is also 40. Now sum of all this is 180 degrees. So 40 plus 40 plus 20, 100. So 100 plus theta is equal to 180. So theta is 80 degrees. Question number 17. Ray of light incident on a polished sphere, multiple reflection and comes out through the same hole. First reflection is happening at point A. Total number of reflections it will have undergo before coming out. So first time it hits here. If this is making 15 degrees, then we can say this also makes 15 degrees. So focus on the angle between this point to center and this point to center. So this is an isosceles triangle, radius, radius. So if this is 15, this is also 15. Now 15 and 15, then third angle will be 180 minus 30, 150 degrees. So first time this goes by, this point rotates by 150 degrees. Like point where it is starting and point where it's hitting. If you check what is the angle subtended, it's gone by 150 degrees. Next time also, this will be the normal angle of incidence is 15. Then angle of reflection is 15. And if we draw one more, again we get an isosceles triangle. This is also radius, this is also radius. So if this is 15, this is also 15. Then again this angle will be 150 degrees. So the point of incidence is rotating again by 150 degrees. So after every reflection, the point where it's sitting rotates by 150 degrees, again 150 degrees, again 150 degrees. Again 150 degrees and so on. So after how many times it's going to come out? Now if you take n into 150 is equal to some n is some number. After some time the total number of times it has turned is some integral multiply of 350 degrees. So after, if n be the total number of reflections, not total number of reflection, you can say how many times it has to rotate by 150 degrees so that it becomes a perfect 360 degrees. So that if it's some 1 into 360, definitely it's not 2 into 360, 3 into 360. Like that, some integer, n is also integer, m is also integer. What is the smallest number for which this is possible? So n by m will be equal to 36 by 15. Or 3 you can cancel, so this will become 12 by 5. So n is equal to 12 and m is equal to 5. Is the many first time when it will happen. But if n is equal to 12 now, then when it goes till here, there is only one reflection. When it goes till here, there is only two reflection. So after rotating by 152 times, there is two reflections. After rotating by 150 12 times, the last time it will not be any reflection, it will simply pass out. So the number of reflection will be n minus 1, which is 11. Because imagine if it was, it's easy to understand this with an example. So imagine if it was perfect. Every time it's rotating by 120 degrees. Then how many reflections it will take? Third time it will go out. So if it's rotating by 120 degrees, definitely 3 into 120 is only 1 into 360 degrees. So this will be that m, this will be that n. N will be equal to 3, but number of reflection is only 1 and 2 because the third time it doesn't reflect. it simply passes through the hole, which is why we are subtracting that one here. Now in question number 18, plane mirror is kept and we have to see the entire image of the electric pole. So when can the entire image of the electric pole be captured by the camera? So if camera has to capture the image of electric pole, light from the bottom of the pole should just, and they're asking minimum length of the mirror required, which means even if you put entire very big plane mirror also, from bottom of the pole, if light is hitting the mirror, it will not reach the camera. This part hitting useless. If it's sitting here also useless, it's not reaching the camera. So where will the bottom of the pole be able to just reach the camera? And same way from top of this, if it's sitting here, it will just go in some other direction that will not reach the camera. So for it to just reach the camera, we need another set of rays. So bottom is just reaching this camera and top is also just reaching the camera. If you find what is the 2 points, then everywhere all the remaining things will be definitely be able to reach the camera and so on. So the basic geometry for this is simply similar triangles. So whatever is the angle of incidence, same will be the angle of reflection theta. And whatever is this theta, same will be this theta also. Now let this distance be equal to some x, then this will become 12 minus x, because this height is 12. Now we can say tan theta is also equal to opposite side, because this distance is given as 10 meters. Tan theta is also equal to, this distance will be 12 minus x divided by this. So value of tan theta will be equal to x by 12. From this right angle triangle, opposite side is x, adjacent side is 10, sorry, x by 10. Same way tan theta is also equal to, from this right angle triangle, tan theta will be opposite side, which is 12 minus x, adjacent side, which is 20. 12 minus x by 20. Or we can also think this right angle triangle, 12 minus x by 20. Solving this, you get the value of x. So 20x is equal to 120 minus 10x. So 30x is equal to 120. So x will be equal to 4. Similarly, we can draw another diagram for y. So light starting from the top, hitting the mirror and just reaching here. Again, whatever is the angle of incidence alpha, same will be the angle of reflection alpha. That will be this alpha also, alternate angles. Let this distance be equal to y. Then tan alpha will be equal to y by 10 from this right angle triangle. Tan alpha is also equal to 18 . So 18 minus 12 is 6. 6 minus y is this. Or basically 18 minus 12 minus y. That will be this distance. So since this is 12 and this is 18, from here it's at a height of 6 meters. Since this is y, remaining is 6 minus y. So tan alpha is also equal to opposite side 6 minus y divided by adjacent side 20. From this right angle triangle. So 20y will be equal to 60 minus 10y. 30y is 60 or y is equal to 2. Now answer for 18th one is minimum length of the mirror is x plus y, 4 plus 2, 6 meters. So 18th one is B. And 19th one, height of the bottom of the mirror from the ground. Height of the bottom of the mirror from the ground is 12 minus x, 12 minus 4, which is 8 meters. So 19th one, B will be the answer. The last question is, density of iron is 3 times that of aluminum. Resistivity is 4 times. 2 wires are made of iron and aluminum. So we have to find what is that resistance. So get the formula of resistance in terms of rho L by area. Here radius is also given, so wire is pi r square. So out of which resistivity is given, ratio, radius ratio is also given, but length ratio is not given, instead density is given. So mass by volume is density. Volume is area into length, density. So length is m by pi r square d. So instead of length, we can write m by pi r square d. So rho L by area, where instead of length, we substituted mass by area into density. So rho into m divided by pi square r power 4 into d. Mass ratio is also given. Now density of iron we call it as A, or iron you call it as 1, aluminum we call it as 2. So resistance of iron by resistance of aluminum is equal to R1 by R2. R1 is directly proportional to rho, directly proportional to M. Inversely proportional to R power 4. Inversely proportional to density. Now we substitute the values. Density of 1 is 3 times that of aluminum. So rho 1 by rho 2 is 3. Mass is 3:1 ratio. M1 by M2. And radius, iron and aluminum means 1 and 2. Radius is 1:2. So R2 by R1 means 2:1. And density, okay, so first one is resistivity. So resistivity is 4 times that of aluminum. Density is what is 3 times that of aluminum, but we have D2 by D1 instead of D1 by D2. So this will be equal to 64. So since resistance of aluminum is 2, what is resistance of iron? 64 into 2, 128 ohms will be the answer. So that's all in this paper. Thank you, everyone.